Uniform circular motion. Whenever you consider circular motion, a body moving along a circular path is said to be under circular motion. Now, if you consider the speed, based on the speed, the circular motion has been divided into two parts. Number one, uniform circular motion. Number two, non-uniform circular motion. What is uniform circular motion? When a body moves with constant speed on a circular path, it is said to have uniform circular motion. So, in uniform circular motion, the speed of the body moving along a circular path will remain the same. If the speed is not constant, that is called non-uniform circular motion. If the speed is constant, it is called uniform circular motion. Now let us consider a point P, and the point P is going to move along a circular path. Let's suppose it is a particle, it is moving along a circular path in anti-clockwise direction. Now it completed one rotation. Let O be the origin of the circular path and R bar is the radius vector of the particle. Now the particle is moving along a circular path. Now the particle has moved from P to P dash and the position vector is R dash bar. Now it is moving with some angular velocity because it is moving along circular path, so it will have angular velocity which is denoted by omega bar. A particle P moves on a circle of radius vector r bar with uniform angular velocity omega bar. Now whenever you want to represent the velocity at a particular point around a circular path, you have to draw a tangent. So when you draw a tangent here, this is the direction of the velocity at this particular point P. In the same way, if you want to represent the direction of velocity at this particular point, now again you have to draw a tangent along the direction of motion. So this is the tangent which is represented by V dash bar. Now here you remember that in uniform circular motion, the speed of the body will remain the same, but the direction will changes. So linear velocity V bar is constant in magnitude but changes its direction continuously. So this you have to remember. Speed means magnitude of velocity. So as the speed remains constant, the magnitude of velocity is constant but the direction changes continuously, because you can see that at P the direction of velocity is along this direction, at P dash it is along this direction. Therefore, the particle experiences acceleration, because we have learnt in third chapter that whenever a body is going to change its velocity, it can change in three ways. Number one, when its magnitude changes, when its direction alone changes, when both the magnitude and direction changes. Here, as the direction of the velocity of a particle is going to change, there is change in velocity. So there is acceleration. In case of non-uniform circular motion, the particle experiences acceleration due to change in both the speed and direction, because in non-uniform circular motion, the speed is also going to change. So the magnitude of velocity as well as the direction both will changes. Now here delta theta represents the angular displacement made by the particle, because the radius vector is moving from point P to P dash, so the radius vector swept an angle which is represented by delta theta. So here delta theta represents angular displacement and omega represents angular velocity. Now whenever you draw a perpendicular, that is by extending V dash bar in backward direction such that it is going to meet at this particular point, now here it is also going to make an angle delta theta bar. So here as well as here the angle remains the same, because if you are going to bring back this particle P dash to P, the velocity again comes back to here. So whatever the angle that is present between P and P dash, the same angle is present between V and P dash. Now here this is the change in position of the particle actually, that is a delta r bar. because it is the initial position, this is the final position. So the change in position is nothing but delta r bar. Now here the curved path, along the curved path the particle is moving, so it is having some distance. The distance traveled along this curved path is denoted by delta s. When the particle moves from P to P dash in time delta t equal to t dash minus t, the line OP, that is radius vector, moves through an angle delta theta bar. Here delta theta bar is called angular displacement. So this is angular displacement. So when the particle moves along the curved path, the radius vector sweeps an angle, and that displacement is called angular displacement. The velocity vector turns through the same angle delta theta and becomes v dash bar at point P dash. The linear displacement pp dash, that is, this is the linear displacement pp dash, because the displacement is nothing but what? A straight line from initial to final point. So this is the displacement, which is denoted by delta r bar. The linear distance delta s is the arc pp dash. So arc pp dash represents distance, linear distance, and the straight line pp dash, that is delta r bar, represents linear displacement. The angular velocity is the rate of change of angular displacement. So delta theta by delta t represents omega. So omega bar is equal to limit delta t tends to 0 delta theta bar by delta t. Relation between linear and angular velocity. So we have understood that whenever a particle is going to move along a circular path, it will have two velocities. One is the linear velocity, another one is angular velocity. Now, what is the relation between linear velocity and angular velocity? The linear velocity is the rate of change of linear displacement, whereas that is v bar is equal to limit delta t tends to 0 delta s by delta t. But delta s is equal to r into delta t, because if you're going to use a sector, actually arc by radius is nothing but angle by, so delta theta equal to delta s by r. So delta s can be written as r into delta theta. Therefore v bar is equal to limit delta t tends to 0 r into delta theta by delta t. That is, in place of delta s by delta t, we are going to write r delta theta. Now delta theta by delta t is nothing but what? Omega bar. So v bar is equal to r times of limit delta t tends to 0 delta theta by delta t, which is nothing but omega bar. So the relation is nothing but v equal to r omega, or we can also represent this as v bar is equal to omega bar cross r bar. It's a cross product. Omega bar, r bar and v bar are mutually perpendicular to each other, and omega bar is perpendicular to the plane containing r bar and v bar. This you have to remember. Acceleration in uniform circular motion. As we already mentioned that whenever a particle is going to move along a circular path, the magnitude may remain the same, but the direction is going to change. Whenever the direction of velocity changes, the velocity changes, so there is acceleration. So what is acceleration in uniform circular motion? Direction of acceleration of a particle in a uniform circular motion. Now you consider v bar and another vector v dash bar. So both at the same particular point. That is delta theta bar, already we mentioned here. Now this line represents delta v bar, which is nothing but change in velocity actually. So if you see the change in velocity, in which direction the change in velocity is present, in the same direction acceleration is also present, because the definition of acceleration is nothing but change in velocity by time taken. Now if you're going to consider this as beta, now I'm going to reduce, that is I'm going to limit delta v bar to a single particular point, that is instantaneous acceleration I want to find. Now as a delta t tends to 0, that is the limit, the region or the time tends to 0, delta theta tends to 0, that means this decreases and beta becomes 90 degree. You can see very clearly here. It means the angle between delta V bar and V bar, that is beta, increases and approaches 90 degree. That is delta V bar becomes perpendicular to V bar. Because both are going to coincide, it is perpendicular only, right? So R bar is perpendicular to V bar and delta V bar is also perpendicular to V bar. So delta V bar is acting along minus R bar, that is opposite to the radius vector. Since the acceleration is a rate of change of velocity, therefore it acts in the direction of delta V bar. As per the definition, in which direction the change in velocity is present, in the same direction acceleration is also present, or it acts in the direction along the radius and towards the center O. So always this acceleration is acting towards the center of the circle. Hence this acceleration is called centripetal acceleration. So centripetal means center seeking or acting towards the center. So as the acceleration is acting towards the center, it is named as centripetal acceleration. I repeat, centripetal means center seeking or acting towards the center. Magnitude of acceleration of a particle in a uniform circular motion. So what is the value actually? Now if you're going to consider this triangle, the two isosceles triangle OPP dash and PAB. Now you can see this is OPP dash and this is PAB. Therefore, both are isosceles or similar. Both are similar triangles. Both are similar triangles. So we can have AB by PP dash. So AB by PP dash is equal to PA by OP. Or what is AB? Delta V bar by PP dash means delta R bar is equal to V bar by R bar. Or delta V is equal to V bar by R bar into delta R bar. So what is the definition of acceleration? Acceleration is nothing but limit delta t tends to 0, delta V bar by delta t. Substitute the value of delta V bar here. You're going to have limit delta t tends to 0, V bar by R bar into delta R bar by delta t. What is delta R bar by delta t? That is nothing but V bar. So A bar is equal to V bar by R bar into V bar, which is nothing but V square by R. This is the formula for acceleration, that is centripetal acceleration. A is equal to V square by R. Centripetal acceleration can be expressed in terms of angular speed, that is omega. We know that centripetal acceleration is nothing but V square by R. But what is the relation between V and omega? V equal to R omega. So if you substitute the value here, you're going to have the expression as A centripetal is equal to omega square into R. So centripetal acceleration in terms of frequency can be expressed as, now omega is nothing but what, 2 pi by t, which is nothing but 2 pi f, that is 2 pi nu, either nu or f. So where nu is nothing but frequency, substitute the value here. So you're going to have the expression as centripetal acceleration is equal to 4 pi square nu square into r. Directions of r, v, omega and centripetal acceleration. The relative direction of various quantities are shown in the figure. Now if you take the circular motion, that is a point P, radius vector r bar, v bar, that is the instantaneous velocity by drawing a tangent, that is omega, because if you can apply omega bar cross r bar, always they both are perpendicular, and the direction of omega is always perpendicular to the plane containing v and r. That is the direction of motion of the particle. That is the direction of centripetal acceleration at that particular point.